Okay, a water tank has the shape of an inverted cone with a base radius 2 meters and a height of 4 meters. Water is being pumped into the tank at a rate of 2 cubic meters per minute. Find the rate at which the water level is rising when the cone is 3 meters deep. What kind of picture am I drawing? It's like a waffle cone. So we've got an inverted, just means an upside down circular cone. Okay, the base radius, so that means my radius right here is 2 meters, and the height of the whole thing is 4 meters. Water is being pumped into the tank. So we've got water coming in here at a rate of 2 cubic meters per minute. What would that represent? It's a derivative. If it's cubic, do you know what that's representing? Anything cubed is your volume. Like squared is usually talking about area, cubed is usually talking about volume. So it's how the radius or the volume is changing. So dV dt. It's being pumped in, so it's a positive 2. If it were leaking out, it would be negative 2. Find the rate at which the water level is rising. So we want a rate that it's rising. So we're looking at how the height is changing. So dH dt is my question mark. At the instant when the water is 3 meters deep. So the time I want, the height is 3. Okay, here's the thing. Volume of a cylinder is pi r squared h. A cone is like a third of a cylinder. So it's 1/3 pi r squared h. Okay, pi is a constant, but r, h, and v are all variables. If I do my derivative right now, I'm going to end up with a dv dt, a dh dt, and a dr dt. dH dt is the one that I'm looking for. Do I have any information at all about the radius? No. So what I want to do is see, can I get rid of this r before I ever do my derivative? Okay, 1/3 pi, I could write that as pi over 3. But I'm asking, is there something else we could put r in terms of so that we didn't have those variables? And so let's come back and think about this whole cone. If I think of this as a triangle, the height was 4 and the radius was 2. And at any given point when our water level, we can measure h and r. These would be similar triangles, right? So we could set up a proportion. So like 2/4 equals r over h. If I'm looking for my r, I just multiply h over, so 1/2 h is equal to r. So at any given point, the radius is going to be half the height. That's useful because I didn't have dr dt, so I needed to get rid of r. So I'm going to change r to 1/2 h. Any simplifying we can do before the derivative is helpful here. So if I square that, I get 1/4 h squared times h, or pi over 12 h cubed. So this one had more work on the front end, but now we're ready to do the derivative, and it's going to be pretty nice. Derivative of v is okay, over here, if I bring down my 3, pi over 12 times 3 is pi over 4 h squared, and that would get a dh dt with it. So then we plug in dv dt was 2, h is 3, and so if I multiply by my reciprocal, I get 8/9 pi. Units, my height was in meters, t, my time was in minutes. So that one was a little more challenging because we had to get rid of r before we did our derivative. And we should be kind of picking up similar triangles has been helpful on a couple of these questions already. We did one Friday where similar triangles worked, and it helped us again here. Questions on that? Let's try another one. A funnel in the shape of an inverted cone. So we again have our cone. "30 centimeters deep," so that's my height. Diameter across the top is 20 centimeters. Liquid is being poured in at a constant rate and is flowing out of the funnel at a rate of 12 cubic centimeters per second. Okay, so this one, water is both coming in and out, just like a funnel. All right. Let's come back to that thought in a minute. Let's focus on this stuff for a second. The height is rising at a rate of 0.25 centimeters per second. So what would that represent? It's how the dh dt. It's rising, so it's a positive 0.25. At the instant when the liquid in the funnel is 20 centimeters deep, so the height at that point is 20 centimeters. Make sure your units all match. You know, if one was in centimeters and one was in meters, you have to make them match. At what rate is water being poured into the funnel? Okay. This one we have to think a little bit more. We have water coming in at a constant rate. Do I know what that rate is? No, so I'm going to call that C. But then it is coming out at a rate of 12. So if it's coming out, that's like a negative 12. So my overall volume, dV dt, it's changing by the amount coming in minus the amount going out. And my dV dt will be positive if my constant is bigger than 12. It'll be negative if it's smaller than 12. All right, so again, we have a cone. So volume is 1/3 pi r squared h. Again, do I make any mention of r or dr dt? No, so let's get rid of that before we do any derivatives, so we can use our similar triangles. In the whole cone, the radius is 20 and the height is 30. So we can think r over h.
Was the diagonal.
Oh, was it?
Yeah.
Thank you. Yep, I just labeled it as radius. So if my diameter is 20, my radius would actually be 10. Thank you. So I'm solving for r, so r is 1/3 h. So 1/3 times pi is pi over 3. I'm replacing r with 1/3 h. We get pi over 27h cubed. All right, now what? Derivative of v is dv dt. Equals, if I bring down my 3, that would become a pi over 9 h squared, and that gets a dh dt. So then if we plug in dv dt would be c minus 12 plus pi over 9, h is 20 squared, dh dt is 0.25. Squared 400 times 0.25 or divided by 4, so 100. So my c is 100 pi over 9 plus 12. Now, obviously not a real pretty answer on a test or quiz. That's how you would have to leave it. On your homework, if you type that in your calculator and gave me the decimal equivalent, that's totally fine. What would my units be?
Centimeters cubed per second.
Yes. Remember, that constant was our volume. Volume is always cubed, so it's our cubic centimeters per second. Any questions on that one? One more for today. We did example 9 Friday, right? That's the last one. Okay, why don't you take a second, read this, and see if you can set it up. It says the height is 1/3 the length of the base. So when I read that, I'm thinking, okay, here's my base, and the height is 1/3 times the base. But then when I keep reading, how fast is the area changing? So if I want to know how area is changing, I'm looking for dA dt. When the height is 5, so my h is 5, and increasing 2 centimeters per second, so my dH dt is 2. Did you guys get these labels correct? What's the area of a triangle? So when I look at that, I currently have 3 variables, a, b, and h. I am looking for dA dt. I have dH dt. Do I have b? Kind of, yeah. I can find out what my base is at that particular instant. Do I have dB dt, or is that what I'm trying to find? I want dA dt, okay. So if I do this derivative right now, I'm going to have 3 rates, and I only want 2 of them. So what I need to do is get rid of this b before I do my derivative. Now that's not how I have my triangle set up. I have my triangle set up to not use h, right? But if I wanted to call this h, I know that the height is 1/3 the base. What would I call this?
3.
3h. That's 3 times as long. So I had to switch that around just because the rate I was given was about the height, so I needed my variable to be my height. So I'm going to call my base 3 times the height. So a is 3 over 2h squared. Then we can do our derivative. dA dt equals 3h dH dt. H is 5, dH dt is 2. So we get 30. What would my units be? Area is always squares, so square centimeters.